Welcome everyone to another episode of S.E.A. Time. I am your tutor, Gareth Beckles, and today we are going to look at decimals. During our time together, we will state the place value of digits in decimal fractions up to hundredths, explore the place value of decimals to hundredths, including expanded notation, compare and order decimals up to hundredths, express decimal fractions using expanded notation, convert expanded notation to decimal fractions, arrange decimal fractions in ascending and descending order up to hundredths, and round decimals to the nearest whole number and tenths. I want to begin by talking a little about place value. The value of a digit based on the position or place in which it occurs in a numeral is known as its place value. The significance of place value becomes apparent when we consider that in our number system there are only 10 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Place value allows us to repeat those digits whenever we have to represent larger numbers. In the numerals 400, 40, and 4, the digit 4 has a different value depending on its place within the numeral. Consider 400. It's a 3-digit numeral. We have 3 places: ones, tens, and hundreds. The 4 is in the hundreds place. Therefore, it has a value of 400. In 40, there are 2 places: the ones place and the tens place. The 4 is in the tens place. Therefore, its value is 40. Consider the numeral 4. There is only 1 place. Therefore, the value of that 4 is 4 times 1, which is 4. The decimal point is important for place value. When we see a numeral represented without the decimal point, the rightmost digit is automatically considered to be in the ones place. In order to represent a fractional value, we would need a numerator and a denominator. The decimal point allows us to pinpoint the ones place, and to the right of the ones place, we can represent fractional values using decimal notation. In the decimal fractions, 4 tenths and 4 hundredths, the value of the digit 4 is also determined by the place in which it occurs. In 4 tenths, the place to the immediate right of the decimal point is the tenths place. Therefore, the value of this 4 is 4 tenths. In 4 hundredths, the 4 is 2 decimal places to the right of the decimal point. It is in the hundredths place. Therefore, its value is 4 hundredths. Consider 444 and 44 hundredths. The decimal point separates the whole parts from the fractional parts. To the left of the decimal point, we have the wholes. To the right of the decimal point, we have our fractional parts. The place to the immediate left of the decimal point is the ones place. So, as was mentioned earlier, the value of that 4 is going to be 4 ones or 4. To the immediate left of the ones place is the tens place. So, to determine the value of the 4 in the tens place, we need to multiply 4 by 10 and we get 40. In this numeral, the leftmost 4 is in the hundredths place, therefore its value is 400. When we look at the fractional parts, that is the digits to the right of our decimal point, to the immediate right of the decimal point, we have tenths. Therefore, the 4 in the tenths place has a value of 4 tenths. And to the immediate right of the tenths place is the hundredths place, and the 4 in the hundredths place has a value of 4 hundredths. A common error when asked about the value of a digit is to consider the place that the digit is in and give that place as the answer. For example, when asked what is the value of this 4, it's in the hundredths place. Sometimes students respond by saying the value of the 4 is hundredths. Hundredths is the name of the place, but in order to determine the value of the 4, we have to multiply 4 by 100, and that gives 400. Similarly, to the immediate right of the hundredths place, we have the tenths place, so the value of the 4 in the tenths place is 4 by 10, which is 40. To the immediate right of the tens place is the ones place. So the value of the 4 in the ones place is 4 by 1, which is 4. We have our decimal point that is separating our wholes to the left from our fractional parts to the right. Observe that the tens place and the hundredths place have been represented using common fractions. 4 in the tens place is represented 4 multiplied by 1/10, so that to the value of that 4 is 4 tenths. The 4 in the hundredths place, to determine its value, we multiply 4 by 100 and we get 4 hundredths. What is different about this place value chart is that the tenths and the hundredths place are now represented using decimal fractions. The tenths place is represented as 1/10 in decimal notation. The hundredths place is represented as 100th using decimal notation. The whole part remains the same, but if we focus on our fractional parts, 4 tenths is now represented as 4 multiplied by 1/10 in decimal notation. That gives 4 tenths in decimal notation. 4 hundredths will now be represented as 4 by 100th in decimal notation, and that gives 4 hundredths. So let us consider 7 tenths. What can we say about 7 tenths? We know that it represents a value that is less than 1 whole. So to represent 7 tenths, we are going to use 1 whole and separate that whole into 10 equal parts. So we have our whole. we have our whole being divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our whole has been divided into 10 equal parts. Each one of those 10 equal parts is going to represent 1/10. So if we have to represent 7/10, we are going to color 7 out of those 10 equal parts. 1, 2, 3, 4, 5, 6, 7. So we have 7/10 being represented. We can show this information using our place value chart. 7/10 represents a value that is less than a whole. So when we consider our place value chart to the left of the decimal point, we are going to have 0 because, as I said earlier, 7/10 is less than 1 whole. Our decimal point separates the whole from the fractional parts. And 7/10, the 7 is going to be in the 10th place. If we are asked what is the value of the 7, we multiply 7 by 1/10 because it is in the 10th place. And 7 multiplied by 1/10 is 7/10. Now this information is presented using our tenths and hundredths expressed as common fractions. We can also present the same information using tenths and hundredths expressed in decimal notation. 7/10, 7 multiplied by 1/10 as a decimal fraction gives 7/10 as a decimal fraction. Another example, 4/100. Once again, this is a value that is less than 1 whole. In fact, to represent hundredths, you would recall that our whole has to be divided into 100 equal parts. So we have our whole, and our whole has been divided into 100 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that gives us our 100 equal parts. To represent 400, we are going to color 4 out of those 100 equal parts. That gives us our 400s. We can represent 400s using our place value chart. 400s is a value that is less than 1 whole. So there are no whole parts. We use our decimal point to separate the wholes from the fractional parts. We have 0/10, and we have 400s. The 4 is in the hundredths place. Our hundredths is depicted there as a common fraction. So we can determine the value of our 4 by multiplying 4 by 100, and that gives 400ths, expressed here as a common fraction. The same information can be represented if we express our tenths and hundredths in decimal notation. Our 4 is in the hundredths column. Its value is represented as 4 multiplied by 100 as a decimal fraction, and that yields a product of 400ths expressed as a decimal fraction. Another example, 1/2700. How is this example different from the previous two? Well, in this case, we have a whole number and we have our fractional parts. So to represent 1/2700, we are going to need two wholes. One whole is going to represent our 1, and to represent 2700ths, we are going to separate the other whole into 100 equal parts, and 2700ths would be 27. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27 hundredths. 1/2700. If we look closely at our 2700ths, we are going to see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 hundredths are equal to 1/10. So every 10 hundredths gives 1/10. So this is 1/10, this is 2/10, and this is 7 hundredths. So 27 hundredths can also be thought of as 2/10 and 7 hundredths. Again, we can represent 1/27 hundredths using our place value chart. In this particular instance, we have one whole. So our decimal point is going to separate our one whole from our fractional parts. 2/10 and 7 hundredths. Once again, remember that every 1/10 is equal to 10 hundredths. So 27 hundredths would be 2/10 and 7 hundredths. If you are asked, what is the value of the 1, of the digit 1 in that numeral? It is 1 times 1, which is 1. The digit 2, its value is not tenths, but 2 multiplied by 1/10, which is 2/10. The value of the 7, of the digit 7, is not hundredths, but rather 7 multiplied by 100ths. Remember, it is in the hundredth place, so 7 multiplied by 100 gives 7 hundredths. And our tenths and hundredths have been expressed as common fractions. Again, same information can be represented if we express our tenths and hundredths in decimal notation. 1 by 1 gives 1. That is not changed from the previous slide. But 2/10 is now written as 2 multiplied by 1/10 in decimal notation. That gives 2/10 in decimal notation. The digit 7 is in the hundredths place. If we are asked what is the value of the 7, its value is 7 multiplied by 100, which is 7 hundredths. Expanded notation. When we are expressing in numeral, in expanded notation, we are simply expressing it as a sum of the value of each digit that comprises the numeral. So we are required to express 56 hundredths in expanded notation. What can we say about 56 hundredths? 56 hundredths is a value that is less than 1 whole. In order to represent it, we must take 1 whole and divide it into 100 equal parts. So we have our whole. Our whole is divided into 100 equal parts. 56 hundredths would be 56 hundredths shaded. Remember that for every 1/10, there are 10 hundredths. So 10 hundredths, 10 hundredths, so that's together 20 hundredths. Another 10 hundredths, so that's 30 hundredths. Another 10 hundredths, 40 hundredths. Another 10 hundredths, 50 hundredths. 51, 52, 53, 54, 55, 56 hundredths. Before we actually express 56 hundredths using expanded notation, let us determine the value of each of the digits that we can find in the numeral for 56 hundredths. We have, it is less than 1 whole, so the whole part of our place value chart, we are going to have 0. Our decimal point separates the wholes from the fractions. We have 5/10 and 6 hundredths. The value of the 5 is not tenths, but rather 5 by 1/10, which gives 5/10. The value of the 6 is not hundredths, but rather 6 multiplied by 100, which gives 6 hundredths. We can also present the same information using our tenths and hundredths expressed in decimal notation. Value of the 5 becomes 5 by 1/10, which is 5/10 in decimal notation. The value of the 6, 6 by 100, which is 6 hundredths in decimal notation. So 56 hundredths in expanded notation, what is the value of the 5? The value of the 5 is 5 by 1/10. What is the value of the digit 6? The digit 6 has a value of 6 multiplied by 100. So 5/10, 5 multiplied by 1/10, 5/10 plus 6 multiplied by 100, 6 hundredths. So that 56 hundredths expressed in expanded notation would be 5/10 plus 6 hundredths. This has been represented using common fractions. We can also present the same information in decimal notation. The value of the digit 5 is going to be 5 by 1/10. The value of the digit 6 is going to be 6 by 100. 5 by 1/10, 5/10 in decimal notation, plus 6 by 100, 6 hundredths in decimal notation. So 56 hundredths expressed in expanded notation is equal to 5/10 plus 6 hundredths. Another example, express 2 and 9 hundredths using expanded notation. With this particular example, our decimal number has whole parts to the left of the point and fractional parts to the right of the point. in order to represent 2 9/100ths, I am going to need 2 wholes to represent the 2 ones, and I'm going to need another whole to represent the 9/100ths. So I have 3 wholes altogether. This is 1, this is 2. To represent 9/100ths, I'm going to look at my third whole and divide it into 100 equal parts. 9/100ths are going to be 9 out of 100 equal parts. So that is what 2 9/100ths look like. We can show this information here on our place value chart. 2 ones, that is going to be to the left of the decimal point because it represents the whole part of our decimal numeral. To the right of the decimal point, we have 0 tenths and we have 9/100ths. Again, our tenths and hundredths places have been represented there using common fractions. What is the value of the 2? The value of the 2 is not ones, but 2 times 1, which is 2. The value of the 9, the digit 9, is not hundredths, but 9 times 100, which is 9/100ths. Same place value chart, but we are going to change our tenths and hundred places and use decimal notation to represent tenths and hundredths. The 2 remains the same as before, but the digit 9 will now be expressed as 9 multiplied by 100ths in decimal notation, which gives 9/100ths in decimal notation. So let us express 2 9/100ths using expanded notation. Value of the 2, 2 times 1, plus the value of the 9, 9 times 100. What is the value of 2 times 1? That is 2. What is the value of 9 times 100? 900. 2 9/100ths expressed in expanded notation would be 2 plus 9/100ths. In this example, our tenths and hundredths have been expressed using common fractions. We can represent the same information using strictly decimal notation. The value of the 2, 2 times 1, plus the value of the digit 9, 9 times 100, expressed in decimal notation. 2 times 1 is 2, plus 9 times 100, 9/100ths. So 2 9/100ths expressed in expanded notation is 2 plus 9/100ths. We are still on expanded notation. This item was taken from S.E.A 2015. This is item 24. Expressed as a single decimal, as a single decimal fraction. 5/100ths plus 3/10ths. You will observe that the 5/100ths is presented first and the 3/10ths second, but that does not change anything. Don't let that confuse you. Addition is commutative, so the order in which we add really does not affect the outcome of the addition. So Let us express 500ths and 3/10ths using a diagram. So we have our whole. I prefer to represent 3/10ths first because I want to reinforce the idea that 1/10 is equal to 10/100ths. So to represent 3/10ths, I'm going to divide the whole first into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each section is going to be 1/10. 3/10ths would be 3 out of 10 equal parts. To represent 500ths, I'm going to next divide our whole into 100 equal parts. Remember, this is 1/10, this is 1/10, and this is 1/10. Each 10 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10/100ths. 500ths, 1, 2, 3, 4, 5, 500ths. This information here can be represented on our place value chart. 0 ones, our decimal point, separates the wholes from the fractional parts. We have 500ths and we have 3/10ths. So that 500ths plus 3/10ths expressed using decimal notation is equal to 35/100ths. Another S.E.A. problem, this time from the year 2014, item 22. Simplify using decimal notation. 7 plus 5/10ths plus 300ths. With this particular item, we have 7 wholes. The previous item had no wholes. So to represent this particular problem, I am going to need 7 wholes initially. 1, 2, 3, 4, 5, 6, 7. That takes care of the 7. To represent 5/10ths, I'm going to take a whole and I'm going to divide it into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5/10ths, 1, 2, 3, 4, 5. To represent 300ths, I'm going to divide this whole into 100 equal parts. And once again, you can see that 1/10 is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10/100ths. 300ths would be 3 out of 100 equal parts. So we go to our place value chart. 7 wholes. Therefore, in the ones place, we're going to have the digit 7. Our decimal point is going to separate the wholes from the fractional parts. We have 5/10ths and 300ths. So that 7 plus 5/10ths plus 300ths is equal to 7 and 53/100ths. This same problem can be solved differently. We have 7 plus 5/10ths plus 300ths. 7 plus 5/10ths expressed using decimal notation. So what I'm doing here is I am writing our common fractions as decimal fractions. So 5/10ths, written as a decimal fraction is 5/10, and 300ths written as a decimal fraction is 300ths. I'm going to do an addition here. We have our places, ones, tenths, hundredths. Decimal point separates whole parts from our fractional parts. 7, 5/10, 300ths. I'm going to add. If we focus on the hundredths place, 0 hundredths plus 0 hundredths plus 300ths, that would be 300ths. 0 tenths plus 5/10 plus 0 tenths, 5/10. 7 ones plus 0 ones plus 0 ones, 7 ones. So we are left with 7 and 53 hundredths. There are instances when we are required to compare decimal fractions, and there are also instances when we are required to order decimal fractions. Consider 3/10 and 5/10. Both those values are less than 1 whole. So to represent it, I am going to use my 1 whole and divide it into 10 equal parts. Once again, 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10, 1 whole. 3/10, 3 out of 10 equal parts. 5/10, 5 out of 10 equal parts. Looking at our diagram here, we can see quite easily that 5/10 is larger than 3/10, or put differently, 3/10 is less than 5/10. So 3/10 is less than 5/10. Remember that the arrow points to the smaller value, or 5/10 is greater than 3/10. What about 4/10 and 35 hundredths? Again, we are dealing with two values that are less than 1 whole. So I am only going to need 1 whole to represent them. I'm going to represent 4/10 first. So as with the previous examples, I'm going to divide my whole into 10 equal parts. 4/10, that would be 4 out of 10 equal parts. To represent 35 hundredths, I'm going to take that whole and divide it into 100 equal parts. And again, you can see the relationship between hundredths and tenths. Each tenth is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hundredths. 35 hundredths would be 10 hundredths, another 10 hundredths, so that was going to be 20 hundredths, another 10 hundredths, 30 hundredths, 31, 32, 33, 34, 35 hundredths. We can see quite clearly that 4/10 is a larger decimal fraction than 35 hundredths. So 4/10 is greater than 35 hundredths. Put differently, 35 hundredths is less than 4/10. We have 3 numerals here. We have 1 and 1/10, 25 hundredths, and 6/10. I'm going to use 2 wholes, and I'm going to represent all 3 numerals using those 2 wholes. Let us start with 1 1/10. Clearly 1 1/10 is a value that is greater than 1 whole, so I'm going to use a whole and I'm going to divide the other whole into 10 equal parts. So each section is 1/10, 1/10, 1/10, 1/10, 1/10, 1/10, 1/10, 1/10, 1/10, 1/10, 1/10. That's 10 tenths in all. So that 1 1/10 would be 1 whole and 1/10. Next, I'm going to represent 6 tenths. Again, I'm representing 6 tenths before the 2500ths because I think you would better see the relationship between the tenths and the hundredths if I do the tenths first, but you could easily do 2500ths before the 6 tenths. It doesn't change the correctness of your approach. 6 tenths, that would be 6 out of our 10 equal parts, and 2500ths, I am going to divide that whole into 100 equal parts. Again, you can see that 1/10 is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hundredths. So 2500ths is going to be 10 hundredths, 20 hundredths, 1, 2, 3, 4, 5, 25 hundredths. So looking at what is displayed there, which is largest? Clearly, 1 1/10 is greater than 6 tenths. Remember that the arrow points always to the smaller of the 2 values, and 6 tenths is greater than 2500ths. So we may be asked to arrange decimal numerals in descending order. Descending order means from largest to smallest. So which is the largest numeral of the 3? 1 1/10 goes first, 6 tenths goes second, and 2500ths, which is the smallest of the 3 decimal numerals, that goes last. We can also express this information like this. 2500ths is less than 6 tenths, and 6 tenths is less than 1 1/10. Ascending order, if we are asked to arrange those decimal numerals in ascending order, we are going to start with the smallest and move on up to the largest. So 2500ths goes first, to be followed by 6 tenths, and finally 1 1/10. Moving along, here we have 4 decimal numerals: 2500ths, 3 tenths, 1900ths, and 700ths. Looking at each of those numerals, we can tell that each represents a value that is less than 1 whole. So I'm going to represent each one of those decimal numerals using our whole. I will initially divide it into 100 equal parts to represent hundredths. 2500ths are going to be 10 hundredths plus 10 hundredths plus 5 hundredths, 25 hundredths. 3 tenths. Remember that every 1/10 contains 10 hundredths, so that 3/10 will be 10 hundredths or 1/10, 20 hundredths or 2/10, 30 hundredths or 3/10. 19 hundredths would be 10 hundredths plus 9 hundredths, 19 hundredths. Of course, we can think of 19 hundredths as 1/10 and 9 hundredths. And finally, 7 hundredths. 1, 2, 3, 4, 5, 6, 7. 7 hundredths. Clearly, we can determine which is largest and proceed all the way down to smallest, or if we want, we can determine which is smallest and move on up to largest. So, ascending order. Remember that ascending order simply means that we are going to start with the smallest value and progress upwards to the largest value. Which value represents the smallest value? Clearly, it is 7 hundredths. 7 hundredths followed by 19 hundredths, followed by 25 hundredths, followed by 30 hundredths, which would be 3/10. But 3/10, as we have been, or rather as I have been painstakingly reinforcing, every 1/10 is equal to 10 hundredths. Therefore, 3/10 would be 30 hundredths. So that is ascending order. 7 hundredths, followed by 19 hundredths, followed by 25 hundredths, followed by 30 hundredths, or 3/10. What about descending order? We are simply going to start with the largest value and move on down to the smallest value. In this case, the largest value would be 30 hundredths, or 3/10, followed by 25 hundredths, followed by 19 hundredths, followed by 7 hundredths. We can also use a number line to represent decimal fractions. This is a number line from 0 to 10. If I focus on the distance from 0 to 1, which would be represented here, I can divide this length, this entire length, into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What would each segment represent? What fraction would each segment represent? If I am dividing it into 10 equal parts, then each segment or each section is going to represent 1/10. 1/10 written as a decimal is 0.1. It is written as 0.1. It is expressed as 1/10. So 1/10, each section, as I mentioned earlier, is equal to 1/10. So that from 0 to the first section is 1/10. We can represent rather 2/10 as well, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and 10/10, or 1 whole. Remember, when you see 1 represented in this form, it simply means we are dealing with a whole that has already been divided into 10 equal parts, and all 10 equal parts are being considered. So, let us see how we can use this knowledge to help us round decimals to the nearest whole. Round 1 2/10 to the nearest whole. So this is our number line from 0 to 10. Where on this number line is 1 2/10 going to be located? Where on this number line is 1 2/10 going to be located? It is going to be located between 1 and 2. So that if we have to round 1 2/10 to the nearest whole, our answer is either going to be 1 or 2, because 1 and 2 would represent the two holes between which 1 2/10 falls. I'm going to zoom in on this particular area here. So let us see where 1 2/10 is going to fall. We already established that it's going to be between 1 and 2. So I am going to divide that segment between 1 and 2, that distance between 1 and 2, into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each distance is going to represent a value of 1/10. Exactly where are we going to find 1 2/10? From 0 to 1, that is 1. So from 0 to the first mark is going to be 1 1/10, to the second mark is going to be 1 2/10, as we have represented there. Now, 1 2/10 is represented right here. So we are required to round 1 2/10 to the nearest whole. As we established earlier, it is located between 1 and 2. 1 and 2 are our wholes. So in rounding 1 2/10 to the nearest whole, we have to decide whether we are going to round down towards 1 or round up towards 2. What we do is represent what is considered the halfway point between our two wholes. In this case, it is going to be 1 1/10, 1 2/10, 1 3/10, 1 4/10, 1 5/10. So 1 5/10 is the halfway point between 1 and 2. This halfway point is important because if the numeral we are required to round off is located to the left of our halfway point, anywhere to the left of our halfway point, we are going to round down. If the number that we have to round is located to the right, that is, if it is located to the right of our halfway point, we are going to round up. In this particular example, 1 2/10 is clearly located to the left of 1 5/10. So, in this case, in rounding to the nearest whole, we are going to round 1 2/10 down towards 1. 1 2/10 rounded to the nearest whole is 1. What about 7 6/10 rounded to the nearest whole? where on our number line are we going to find 7 and 6/10? 7 and 6/10 is located between 7 and 8. That is right there. So, in rounding 7 and 6/10 to the nearest whole, we have to decide whether we are going to round to 7 or we are going to round to 8. So what I'm going to do, I'm going to zoom in on this particular area here. So we have 6, 7, 8, 7 and 6/10 is going to be located between 7 and 8. So I am going to divide that section, that distance between 7 and 8, into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have divided that distance into tenths. Let us determine where 7 and 6/10 is going to be. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10. So 7 and 6/10 is going to be located right there. So we have to round to the nearest whole. Let us identify the value that is halfway between 7 and 8. 1, 2, 3, 4, 5, that is 7 and 5/10. So this is our halfway point. If the value that we have to round is to the right of our halfway point, we are going to round up to the nearest whole. If it is to the left of our halfway point, we are going to round down to the nearest whole. In this case, 7 and 6/10 is beyond the halfway point, so we are going to round up towards 8. So 7 and 6/10 rounded to the nearest whole is 8. In the previous examples, we were rounding to the nearest wholes. Now we have an example where we have to round to the nearest tenth. So imagine a number line. I am focusing on the section between 0 and 1. So that what we are seeing here is our number line between 0 and 1 being divided into 10 equal parts. So this is 1/10, 2/10, 3/10, all the way up to 10/10, or 1 whole. To show hundredths, remember that each 1/10 can be divided into 10 equal parts to represent hundredths, because 10 hundredths make 1/10. So 24 hundredths is going to be located between 2/10 and 3/10. Remember that 1/10 is going to be 10 hundredths. So from here to here is 20 hundredths, and 24 hundredths is going to fall between 2/10 and 3/10. So I'm going to zoom in to that particular area there. So 24 hundredths is going to fall between 2/10 and 3/10. So I have divided 1/10 from 2/10 to 3/10. Remember, that is 1/10, and each tenth has 10 hundredths. So I have decided to divide 1/10 into 10 equal parts. Each section represents 1 hundredth. So that 24 hundredths is going to be 10 hundredths plus another 10 hundredths, 20 hundredths plus 1, 2, 3, 4, 24 hundredths. The decimal fraction 24 hundredths is represented by this section from 0 all the way up to there, 24 hundredths. So we need to decide in rounding our 24 hundredths to the nearest tenth whether we are going to round to 2/10 or we are going to round to 3/10. If we identify our halfway point between 2/10 and 3/10, we have 1, 2, 3, 4, 5. So 25 hundredths would represent the halfway point between 2/10 and 3/10. What was mentioned earlier, if the value that we have to round is located to the left of our halfway point, we are going to round down. If it is to the right of our halfway point, we are going to round up. In this particular case, 24 hundredths is to the left of our halfway point, so we are going to round 24 hundredths down to 2/10. 24 hundredths rounded to the nearest tenth is 2/10. Another example, this time we are to round 87 hundredths to the nearest tenth. 87 hundredths is going to be located between 8/10 and 9/10. So I am going to zoom in on this particular area, 8/10 and 9/10. I am going to divide this distance. Remember, this is 1/10 from 8/10 to 9/10. That is 1/10. That distance is 1/10. And if I divide 1/10 into 10 equal parts, each section is going to be 100 because there are 10 hundredths in 1/10. So where is 87 hundredths? 81 hundredths, 82, 83, 84, 85, 86, 87 hundredths. That is going to be right there. So we have to decide whether we are going to round 87 hundredths up to 9/10 or down to 8/10. What do? We identify the midpoint between 8/10 and 9/10. 81 hundredths, 82 hundredths, 83 hundredths, 84 hundredths, 85 hundredths. Clearly, 87 hundredths is located to the right of our midpoint, so we are going to round up. If the value we were asked to round is located to the left of the midpoint, we are going to round down. But what if the value lies exactly on the midpoint? What if it were 85 hundredths, so that it would have been located exactly on the midpoint? In that case, if the value we are required to round is located exactly on the midpoint, we round up. Not down, but up. In our particular example, 87 hundredths, lies to the right of our midpoint, so we are going to round up to 9/10. 87 hundredths rounded to the nearest tenth is 9/10. And this particular example is an actual S.E.A. item taken from the year 2014. Write 3 49 hundredths to the nearest tenth. Have our number line. We have to decide where on our number line we are going to find 3 49 hundredths. 3 49 hundredths is going to be located between 3 4/10 and 3 5/10. So I am going to zoom in on the area between 3 4/10 and 3 5/10. In rounding 3 4 49/100, sorry, to the nearest tenths, we have to decide whether we are going to round to 3 4/10 or we are going to round to 3 5/10. I am going to divide the distance between 3 4/10 and 3 5/10 into 10 equal parts. Remember, from 3 4/10 to 3 5/10, that is 1/10. And if I divide 1/10 into 10 equal parts, each part is going to represent 100, because 10 hundredths make 1/10. So where are we going to find 3 49/100? 41, 42, 43, 44, 45, 46, 47, 48, 49 hundredths. So 3 49/100. It's going to be right there. It's very close to 3 5/10, but let us be sure. We are going to identify next the midpoint, the halfway point between 3 4/10 and 3 5/10. That is going to be 3 41/100, 3 42, 43, 44, 4500. That is 3 45/100. That is the midpoint between 3 4/10 and 3 5/10. If the value that we are required to round is to the right of our midpoint, we are going to round up. If it is to the left of the midpoint, we are going to round down. If it is exactly on the midpoint, we are also going to round up. In this case, 3 49/100, that is clearly to the right of our midpoint, so we are going to round up. So that 3 49/100 to the nearest tenth is 3 5/10. Well, boys and girls, we have come to the end of today's session of S.E.A. time. Before I say goodbye, I want to invite you to visit our website, learn.moe.gov.tt. A lot of additional learning materials are available there to you should the need arise for additional support. So I want to thank you for joining us today. It has been my pleasure to be your tutor. All the best as you prepare for S.E.A. 2020. Until the next time, thank you and goodbye.